Hello and welcome. This is the Bits vs. Bytes podcast. I'm your host, Amr Grigic, and today with me is Sanne Menning. She is a data scientist at Albert Heijn. Welcome, Sanne.
Hi, thanks for having me.
No problem. What I would like to do is start off with a little bit about your background and also how you got to work at Albert Heijn.
Okay. Well, my background is a bit different from what usually is expected from data scientists. I have a background in neuroscience. I studied human movement sciences and then neurosciences.
Okay.
I have a PhD in neuroscience. I specialized in brain MRI.
Okay.
And then I was a bit disappointed in the academic world. And I wanted to move a bit faster, see more results. So that's why I changed into data. Mm-hmm. Most of my research was data. So analyzing MRI is a lot of statistics and a lot of coding. Mm-hmm. And that's what I liked best. Mm. So then I changed to industry and did a lot of analytics projects at different companies in outdoor lighting, smart lighting.
Okay.
That's where I started off. Then I went into consulting and I worked at a lot of different companies, concrete floors, a bank. I ended at a company that grows flowers. And now I'm working at Albert Heijn, or Ahold Delhaize, but the Albert Heijn tak. Mm-hmm. So the supermarket data, a lot of customer data, financial data.
So what spoke to you about neuroscience in particular? Because that's interesting to me because you don't hear a lot of people going into that field. But
yeah. Well, I started at human movement sciences, and that was because I was a rower at the national level, and I really loved all the physical stuff and like the more scientific stuff in sports. So I started studying human movement sciences, and there we had this very popular professor, and he was a neuropsychologist. We had a lot of neuroscience or neuroanatomy, and I liked that more than the sports. I also thought there would be more future in that than the sports part of human movement sciences. So that's why I changed into neuroscience. And then I liked MRI best because it's more quantitative. Mm-hmm. I liked the technology. I studied brain stimulation because I liked all the techie stuff.
That's interesting because a lot of people don't even know that, for example, of course, people know what an MRI is, right? Mm-hmm. They know that it's a scan and stuff like that, but they don't know that there's a lot of data surrounding that, right? Because usually what they'll do is they will see that kind of picture that you know from the MRIs and don't think a lot about it in a different sense.
Yeah.
So what from my curiosity, mm-hmm. what kind of data comes out of that, right? So what can you even do with that data that comes out of that?
There's a lot of different data. It's all it's mostly frequencies that you have to analyze into something that makes sense. Mm-hmm. So all these television shows where you see like brain activity in real time, that's really hard because analyzing brain activity, it takes a lot of time. It's 4D data, 3D data in the brain. So there are a lot of 3D pixels and you have to analyze all these frequency signals, apply statistical models. The funny thing is when I was studying human movement sciences, we had to do Fourier transforms in Excel. I later learned that it's just a function in MATLAB, but we had to do it in Excel. So that was very complex. And during that course, I was only like wondering why we should learn this. And then when I went into MRI, I finally, saw the usage of it because it's all frequency data. And in MRI, all you do is Fourier transforms to make sense of the signals. There's a lot of data in there, and there's also a lot of discussion still about the statistics. So that is very interesting.
Yeah, and I think it's hard to quantify these kinds of things surrounding, for example, your brain, because we know so little about what actually happens in the brain.
Yeah,
we're all like, okay, this when you do this, for example, I had a podcast with someone that was doing kind of neuromarketing as well, where they were also putting on some kind of, I think it's some kind of device on your head to see what happens when you, for example, watch a commercial or whatever. And it does give you some sense, but it's still the data isn't really concrete on that if it's always correct at that time.
Well, the thing with this functional, so that's probably EEG. There's some functional MRI in neuromarketing.
Sure.
But the thing is, there's so much noise, and to really pick up a signal is very hard. And also, we don't really know what the signal exactly means. So there's, when I was doing my PhD, the next hot thing was resting state fMRI. So usually you do a task, and then you try to figure out what the brain activity during that task is, compared to when you're not doing the task, to get the signal to noise ratio right. And then someone discovered that if you're just lying still in the MRI scanner and don't fall asleep, there are a lot of networks that you can find. If you use principal component analysis, you can look at, temporal patterns and spatial patterns, and then you see like working memory network, you can see attentional networks, and they light up. So then everyone figured we have to study this in disease to see what's different. So then all these publications came out with, Alzheimer's patients. We can see that this specific network and that specific region is deviant from healthy subjects. Yeah. But we have no idea what resting state fMRI or the signal that we see, what it means.
Yeah, exactly.
And I think that's where I was disappointed in science, that it's relatively easy to get money for research in disease. So, in the Netherlands, we have the Dutch Cancer Foundation where you can get a lot of money. There's the Alzheimer's Foundation. You can get money to study disease. But to get money to study what resting state fMRI means, that is very hard. And I think that this sort of fundamental research to understand what these new technologies can do and what it means for us, that should be more important.
Yeah, you're kind of skipping a step there, right? Because you're already going to look at the solution for what is happening, but you don't even know the actual cause that's causing this, for example, this disease or whatever.
Yeah,
and that's I think. I think that not a lot. Usually science does that correctly, where it really looks at the basics and stuff like that. But in this kind of field, it's still. We don't know. That's the problem. We still don't know. So we don't even... and it's weird to me that they don't do that first step, right?
Yep.
They look at the basics and then say, okay, from there we can go and see what is actually happening. Yep. In technology, it's the same thing, right? If something doesn't work on the server, you're going to try and find out what the actual cause is, right?
Yeah.
And that's that doesn't happen that often. For example, for a brain, it's a little bit trickier to find that actual cause. But what I would like to know is, so you have a lot of math involved in this, right? So there's a lot of math in that. So what do you like about math? Because from my perspective, I really don't like math. So it's not that I don't like it. It's more like. It's too much. I don't like working with the numbers, right? I like being more creative in that sense. But what? And of course, you can be creative with numbers as well. But what do you like about math and stuff like that?
Well, what I really like is that 1 + 1 = 2.
Yeah.
But then you get into data science and you discover that 1 + 1 equals what you make out of it. So it kind of depends on the data that you have and the noise that's in there, especially if you work with like human data, people just typing in stuff, or there's so much noise in there. I have been looking at transactional data at Albert Heijn, and it's very hard. People behave differently, and it's very hard to find very clear patterns in that.
Exactly. Yeah.
So, on the one hand, I really like the exactness of mathematics, and in data science, I like that you can be creative to find the solution so that 1 + 1 = 2, so that you can get to the mathematical truth.
Yeah, that's crazy, because that a lot of people don't know that it's not that you manipulate data, right? So you're doing different calculations over it. It's basically that. So you're not doing 1 + 1 = 2. You're pretty much doing 1 divided by 1 or something like that. You're doing it differently.
So we call it manipulation, but manipulation also has like this sort of negative sound to it. And that's not what we do. We try to find the truth. And that's what I like more about business. We really want to find the truth because a lot of processes and money is depending on it. Whereas in academics, you look to kind of... a lot of people are not going to like me saying this, but you're trying to find what you have hypothesized.
Yeah, exactly.
And I think in business, at least in my experience, it's more about real truth finding. So you try to find the data you need to show what's actually happening.
Yeah, because you're going to base some decisions on that, right? You're going to base business decisions on that. And also, what happens a lot is that a lot of people want to quantify data to, for example, determine what to invest in, what's the kind of the new technologies that we need to invest in. And you can't do that on a half kind of truth, right? You need to have the exact reason why someone is doing this. And that's hard, as you said. So what does a typical day look like to you? So say, for instance, you come in the office in the morning, and what's kind of the process that you go through to start?
Well, it kind of varies. I'm working on a larger project now, so we have a stand-up every day to see where everyone's at and what has to be, if we have any difficulties getting to the end of our sprint. But like most of the time, I'm coding. I'm just working in R or in Python, just modeling, like getting data from the sources, feature engineering to get the variables in a way that we can input them in a model, that they are meaningful, and then there's the modeling of the algorithm. So that's a very large part of my day. There are meetings with business owners. So I'm doing a forecast at the moment, and there's one person who is the business owner, and we talk a lot to make sure that the data I am using for the forecast is meaningful. But I'm also talking to an engineer to make sure that the data can be used in a way that we can productionize the solution. So there's a lot of meetings as well, but mostly coding. I try to minimize the meetings and make that most efficient.
But that's interesting because that's something that a lot of people don't realize when they are talking about data scientists and what they do. Because a lot of people are like, okay, so you're using some kind of tool, for example, Power BI or whatever, and just clicking together some dashboard and getting some data and doing some transformations over it, and that's it. And people are like, okay, that's cool, so I want to go into that direction, until they actually realize what the actual work is, right?
Yeah.
So you're coding a lot. You're working with Python and R, which R is kind of a coding language as well. So what's interesting to me is how would you describe what a data scientist is actually? So how would you describe that?
That's a very hard question because there's so much going on in the field of data, and there are so many job descriptions, so many job titles, and everyone interprets it a bit different. If I look at myself, I don't really like the dashboarding part. I used to use Power BI at Albert Heijn. We use Tableau, and I don't want to dive into that, so I try to stay away. In my previous job, I used Power BI now and then to kind of get a first feeling of what the data looked like. But most of the time, I get a question from the business. I try to figure out if it's something that will make sense to them, if it's really going to help their business. So there's some business consultancy in that. But there's also a lot of trying to come up with a result that they can understand, that they can trust, and that we can really put into production so that's going to help them. And then the biggest part is getting all the data together, cleaning the data, and writing the algorithm. And I think that usually the algorithm part is very small. Mostly I work together with engineers a lot to get the data and clean the data.
Yeah. So that's interesting as well, because when you look at, for example, Python and R, I can imagine that there is a reason why you like that more over such a application like Tableau or for example, Power BI. So what's your reason for having a preference for the other one? So for Python and R.
Yeah, because you can see what's actually happening.
Yeah.
So that's during my studies, we used to use SPSS a lot.
Yeah.
And it was mostly the clicking part, not the syntax part. And you just click and you have no idea what's happening. And I want to see what's going on. You know, I want to see how data is combined, what transformations are being done, or actually I want to do the transformations myself and not have the software do it for me.
Yeah.
Because steps can be done that I don't understand or I don't want to happen. And with code, you feel more in control.
Yeah, and that's what happens a lot with if I look at normal development in that sense, it has a really strong connection to that when you look at it that way as well. Because, for example, if I'm doing something and I'm trying to create something, I don't want the program to do something that I didn't expect, right? Or something that I don't see, something that's happening. Of course, there's always something happening underwater, of course, if you can call it like that. But it's you don't want to have the unexpected happen.
Yeah.
That's the thing. So, for example, you're putting on a transformation or you're doing something and it gives you something, and then you look at what you get from Python and R, and you're like, okay, this isn't even the same. It's not even in the same ballpark, right?
Yeah. Well, that's with we spoke earlier.
Yeah.
And I told you about an algorithm that I used with a clicky kind of software solution.
Yeah.
And I got an answer and I didn't know how to interpret it. And then it turned out I used categorical data and I could only use numeric. And apparently the software does some sort of transformation because it could get to a solution.
Yeah, it does show something.
Yeah, but I couldn't figure out what the transformation was. So I didn't know what kind of steps it took in between. So I couldn't interpret the end results. And that's why I don't want that. I want to be in charge of the type of transformation so that I know that I can trust it, so that I know how to interpret the end results.
Yeah, and that's something that, of course, Power BI, and that's a tricky thing, I think, about creating such a solution as Power BI, as Tableau and stuff like that. Because there's so many variables. That data can be whatever you think about, right? And then you need to be able to say, okay, this is going to work this way. Because when you look at, for example, Excel, which is also some form, you could even use it as some kind of a database if you wanted to, right? Or just a data file in that sense. But that's easier, right? There's just the data that you put in there will probably be, most of the time it will be the same, right? It has 2 axes and that's it, right? And that's not the case when you just have a large data set where you're like, okay, I can just query whatever I want on it, right?
Yeah. Well, I think
you still
Power
have
BI
dimensions, of course. But
Well, I think Power BI and Tableau have a lot of good features.
Yeah.
And they can be very useful in business to visualize or to show like higher management what's going on. But it's also very dangerous because a lot of interpretation can be misused, or like you need experts to build the dashboards in a way that people understand. And I think that what you see is that UX is getting more important in this field, and that's, it's going to help make the results like
better,
get across in a better way.
And it already helps that there are things like this, right? Because previously you didn't even have that. You had like R and stuff like that, but I've tried to do anything in R and I'm like, I really don't understand what's happening here. Even the easiest things, right? And I'm not a developer by trade, so that maybe that's the problem here. But usually I can get something from it, and now I'm like, okay, this is really a job, right? This is really someone that needs to be an expert in these kinds of things, because you're doing calculations, you're doing all kinds of things. You need to know what those calculations are saying, right? And this algorithm or whatever you try to put on it. So when you look at these kinds of things, what are some of the things that you can, for example, get out of data that usually people wouldn't see, right?
I think it's the more complex relations. Like we humans, we maybe can interpret like a 2-dimensional, maybe 3-dimensional relationship, and after that we're lost. We have no idea what's happening. So if it's like more complex and more different features, then data is going to be really helpful, and also like very large quantities. You know, if you have like 1 million rows of transaction data, like no human's going to be able to make sense out of that. It's going to be years before you've scored all of that.
I can imagine, because sometimes it's even hard to do it on 50 rows, let alone on 1 million. And also, are there some things that have surprised you? So when you're like looking at data and you're looking at it and you're like, okay, this is weird. This is not something that I expected. Are there some things?
Well, usually it was my mistake, because usually the data confirms what you know from the business. And if it's something really weird, I get very suspicious, and I try to invite a lot of different experts to talk it through and see if they understand what's happening there. So I remember a project that I did with a client, and it had something to do with weather data and accidents. And I found a relationship, and I just couldn't make sense. It was like, if it snows more, then it's safer on the roads. That was kind of the conclusion.
That's
and I corrected, I corrected for like the amount of traffic and a lot of different factors. And then there was an expert, and he said, well, yeah, that makes sense, because there was some technical thing that they did, and that explained the entire relationship. So usually the data confirms our suspicions or what we know. Yeah,
so the data doesn't lie in that sense. It does make sense, because when what you put in it, you will probably get out of it as well. So when you put in, for example, some kind of algorithm or whatever, you wouldn't expect that algorithm to throw something else than what you actually meant for the algorithm to do.
Yeah, and I think that's also one of the dangers in data science. You know, you get what you put in, and like our prior beliefs are very important in how we build an algorithm. So there was an example from Amazon. They did a resume selection for IT jobs, and in the past, not that many women got into the IT jobs. So the model just rejected all the women because they weren't very successful in the past. And those are things that you really have to think of. Those kind of biases, you know, usually unconscious biases are very important in building these algorithms, and you really have to think them through. But also, if you put an algorithm in production, it's going to be a self-fulfilling prophecy. If you have a product recommendation, people are going to buy those products more. And it can also, like, if you buy a blue dress somewhere online and you only get blue dresses recommended after that, you're going to annoy a customer. So I've been talking to Ilko. He was on your podcast earlier, and we were kind of thinking about, you know, can you throw in some sort of wild cards, or how can you make this more original? You know, you kind of want the recommendations to adhere to the customers, but you also want to surprise them and recommend something that does fit in, but is not exactly the same as all the other things. So those are interesting discussions to have.
Yeah, and I'm thinking about two cases that come to mind when, for example, on Amazon, because when I'm looking for example, I'm looking for a USB cable or something like that. All the other suggestions are just USB cables, right? And I'm like, okay, maybe some suggestions would be something else, right? Something that has to do with a USB cable, but it's not a USB cable in that sense. Because I'm not going to buy 3 USB cables. I'm just going to buy one. That's the thing. But also the other example, I listened to a podcast a while ago about Twitter. So where they have huge amounts of data, and it's all in text, right? So and there was also a discussion about biases in that sense as well. Like, okay, you're putting all these kinds of rules in place, but are those rules fair to everyone that's trying to use the platform, right? And they're doing algorithms on that. For example, if someone says this and this, then it's probably not good, and we'll block that person, or we'll remove the tweet or whatever. And that's interesting to me, because that means that however way you slice it, you will always get some kind of bias in how they create the algorithms, and that's on a very, very large scale. And it's even harder because it's just text, right? And we have trouble understanding text, or at least interpreting it in a kind of in a machine learning fashion, if you can call
Definitely,
it like that.
yeah. I heard of some people trying to detect sarcasm
Oh,
in text.
yeah. That's hard.
It must be so challenging. It must be so challenging.
Yeah.
But it's very interesting.
Yeah. But also things like I was trying that with text analysis with, for example, Amazon Comprehend, which also gives you that service. And I was trying with different kinds of things. So they don't support Dutch, so I had to translate Dutch to English and then walk it through Comprehend. And I did the service was not bad, right? And it did say that it's a positive, right? Or a neutral, something like that.
Oh, okay.
So it does kind of pick up those nuances, right? Because not bad, people would say, okay, we'll pick bad because that's kind of a key phrase, and then it's probably negative. Or there was a review that we tried, and it said, okay, the company was great, but the car that I bought broke down after 60 miles or something like that. Something like that. And it was really interesting to see that it actually said mixed. So it actually said, okay, this first part is probably positive, and the next one is probably negative. So it saw that it's a mixed reaction, and that's, I mean, the text analysis field is still coming up, of course, but people are getting really good at it because I didn't expect that.
No, especially if you can translate it to English. Then.
Yeah, that was also one thing. I was like, okay, what happens if I make a typo in this?
Yeah.
Because it can happen. For example, we get a review or something like that. Someone puts in a typo and it still got what I wanted to do.
Wow.
So it's getting better, but they have enormous amounts of data sets to try that machine learning on.
And that's the thing. I think that in data science, you can see that specific parts of data science, such as text analysis or computer vision, that's more brought on as a service by like Microsoft or Amazon or Google, because they have the enormous amounts of data to really do this properly. The data and the people, and you need a lot of specialists to do that, and to build those kind of algorithms yourself, that is probably not worth the effort.
No, and that's why a lot of companies are using them, right? I mean, it makes total sense. For example, if you have 1 million reviews, let's say you have 1 million reviews, that's still not enough to train a good data set. And that's the thing. They have billions and billions of these kind of things. So every time I push something to that API, probably they are going to use that to get their machine learning or their model better in that sense.
Well, and these are like text is rather generic. You know, there may be specific branches. So if you look at like hospital or like medical information, that might be a bit more specific, but it's usually very general. And I think if you look at like the models that are built for someone's core business, then you want to develop it yourself and you want to be in total control. You want to understand what's being done, but then in computer vision and text, it might be just easier to adopt something that works very well. Because
it's basically always the same thing.
Yeah.
It's not data that, well, of course you can have different languages, but in most cases it's the same data, right? It's just text, it's words, it's sentences. So when you look at data science, so say for example, I have someone that wants to start in data science and wants to go in that direction. What kind of advice would you give them to start with? So what would they have to be into? What do they have to start learning or whatever?
I think data science is kind of, you need to focus on the business, but that's in pretty much everything. I think that in pretty much every function in business, you need to know what's going on, where you can add value.
Yeah.
Specifically for data science, it's the math part, math and statistics. You need to know the basics on that. Like, get back to algebra and that kind of stuff. Probabilities, and also the coding part. Because the coding part is what I'm working on most of the time. So if you know those two, and now I don't have a computer science background, so I'm trying to get more into that as well to better understand that. I'm working on Spark now through Databricks, so there's a nice layer on that. But I'm trying to understand what's actually happening there, because it's also important if you work with these really big data sets. It's important to understand what the computer does with them and to be able to optimize your code so that the algorithms run in a timely fashion.
Yeah. So how was that transition like for you to go from an education that doesn't go into that computer science part, but to actually going into a role that has that so much, that's actually revolved around everything surrounding computer science? How was that transition like for you?
It's very interesting, and I've been working together with a lot of people who have that background and try to learn as much from them as possible. A lot of YouTube videos on object-oriented programming and that kind of stuff. So YouTube, podcasts, a lot of online courses. So but it is a challenge to understand that more and to find the time to also study that. Like, that's the thing with data science. It's so broad. There's so much you have to know. Yeah.
That's the same with for example, developers that are starting off as well. If you want to start developing, the thing is, what I'm thinking about is that what I've noticed myself in learning these kinds of new things is that usually I really get good at something, or at least I think I get good at something, but by just having the cases, right? By having the cases that you want to do. So say, for instance, someone says, okay, I want to know why this and this is happening. For example, in your case, someone is asking you that. You'll look at that and will say, okay, then I need to get this and this and this information, and in this way I could probably combine it. And I think that's the only way to really learn these kinds of things really good, is to actually have the practice to do these kinds of things.
Yeah, because just taking the courses or just listening to someone explain it to you, you don't really grasp it. So it gives you some sort of starting point, but then to really learn it, you just have to work on projects. Yeah,
and education needs to change in that sense as well. I've talked to about that on a podcast. Not my podcast, but another podcast.
I just listened to one where you were talking about the apps that were being developed in education.
For sure. And another one that I was doing was also surrounding a bit about other types of education and stuff like that. And the question was more like, okay, do you feel that it's up to par with what it has to do in this future? And I'm like, I feel like there is too little focus on the actual practical part, right? Yeah. Actually going into a business, seeing what's happening there, and helping out with a project there, right? Yeah. Because that's the way I learned all the things that I learned about servers and stuff like that. I didn't learn it by just going to school, because pretty much school didn't learn me any of that, of those kind of skills that I needed later on.
Yeah. And I think especially in university, like I did a research study, so everything was focused on getting your PhD and getting you to this professor position, but there are only very limited spaces. So I think I don't know the exact numbers, but I think like 5% of the people who get a PhD actually become a professor. And the entire education is like devoted to getting you into that position, which is really weird, because 95% of the students is not going to get there.
Yeah. And they switch it to totally different things. Yeah. I had someone, an old colleague of mine, who was he had like a major in art or something like that, and he became an engineer. So it can really go all kinds of ways in that sense. Yeah. But, getting back to this kind of data science and stuff like that, how do you see that evolving in the future? So how do you see it changing in the near future?
Yeah. I think data science is becoming more mainstream. I see that the larger companies are really investing in data scientists and in building solutions. The smaller companies, I don't think they kind of trust it enough yet, and they don't have the money to hire a data scientist to do it for them.
Makes sense.
Yeah, totally. So for them, like, it's good to see that these services are being provided by the bigger companies, so they can also use it. So I think that's an interesting development. There's a lot going on AI and singularity, and is that our future? And I think that is still quite far away. Some people may call me naive, but if I look at the solutions that are being built now, and if I look at how advanced we can get using those, I feel that AI is not...
It's a hype.
It is. And what you can see is that a lot of people say they do AI, and it's basically a lot of complex business rules.
Yeah, machine learning, pretty much. Yeah,
the same. Yeah, and I think like the machine learning part, that is like it's been around for a very long time, and we're getting better at it, and more people are getting into the field, and companies are investing in it more. So I see that is developing, but even then, there are a couple of companies that are way ahead, and then the rest is really lagging behind.
Yeah,
and it's interesting to see if they can catch up.
Yeah.
Or if it's just going to be like these very big companies that are going to rule the world.
Yeah. And I think you're right on that, because when I look at it, there was a podcast with Joe Rogan, which he had Naval on the podcast. He's an investor and stuff like that, but he was talking a little bit about this AI stuff as well. And funny enough, he was talking about the human brain as well, because he was like, okay, we don't even know how the human brain works, let alone create an artificial kind of brain, right?
Yeah.
And that made total sense to me, right?
Yeah.
Because if you're going to create something that's going to create thoughts of its own, then you really need to know how thoughts are created at all, right?
Yep.
And that's something that a lot of people think, okay, AI. As I said, mostly you see the applications you see are recommendation engines and stuff like that, and you're like, okay, but that's not what you're trying to get to here.
Yeah. But we are also seeing a lot of like the autonomous vehicles.
Yeah.
I've seen some at one of the distribution centers at Albert Heijn. It was pretty cool to see them driving around.
You have the delivery robot as well, right?
Yeah, but it's in Eindhoven, it's like this one small cart.
For sure.
But it is very cool to see that, and I think that's going to change our future. If we have the autonomous vehicles.
Yeah.
But that's what I love about data science, is that there are so many, like the psychology, the ethical part, the legal part. It's so complex and so much comes together that it's going to be very interesting to see how that takes off. And if you look at some companies where maybe the ethical considerations are a bit different from what we have here, it's going to be very interesting to see if
how that's going to evolve.
How that's going to evolve in those countries.
Yeah, and that was also something that came on the podcast as well. It was more of a discussion like, okay, say for instance everybody was an engineer, right? Everybody was into code, and he was like, okay, then we would probably have solved almost anything that you can think of, right? Like these things, like delivery robots, like everything like that. And we would only focus ourselves on the creative things, because that's what we humans are good at, right? The creative part. And he was like, yeah, for example, they were like, okay, are they going to be coders in the future, right? And he was like, don't fool yourself. There's not going to be someone that's going to create something that's going to write code for you. That's pretty much recreating our brain again. So it was such a fascinating podcast in that sense, because it goes into these kind of things where they're talking about, okay, is this actually a reality, right? And most of it boils down to just being a hype at all.
Yeah, I think that's the thing, like real creativity. Like there are people who say, well, you have I don't know if you've seen the Next Rembrandt project.
No. But
it's still like they studied all these paintings, they looked at different layers, and then they made a new one based on the pattern evolving from all the previous Rembrandts.
Yeah.
Which is interesting, but it's just, taking all the previous ones together and then creating a new one that is very similar, and it's is it truly creative? And then with music they say you teach a robot a lot of music and then they will come up with something themselves, but I'm kind of curious how original it actually is.
They were talking about the example where AI, if you can call it like that, quote unquote, but was beating people at games, right? Mm-hmm. So at Go and some, I think it was like StarCraft and some games at least. And he was like, yeah, but still, all those things are confined, right? It's not totally open in that sense. It all has rules. It's all man-made rules even. So it was like, okay, you're not really getting to the creativity part then. But
and also they can only do that.
Exactly.
AlphaGo can play Go. But it's the more generalized intelligence that humans have that we've not been able to mimic that.
Yeah, for sure. So to wrap up, I have a last question.
Okay.
So you had this whole journey into data science. So what are you most proud of since you started this kind of path that you're on? Hardest question ever.
Yeah, it is the hardest question. Well, I've been working in this field since the end of my PhD, or where I didn't work on my PhD full time anymore. That's only been 4 years. And looking at where I'm at now and all the knowledge I've gained, so I had a pretty solid statistical background, but now also being able to program all these different things, and also knowing so much more about IT and how computers work, being able to work on Spark. That's something I'm proud of, that I got to wrap my head around that, and come from this academic environment where you have all the time to really dive into this one very narrow topic, and now being able to help the business with all these different questions and just building solutions that are actually going to have effect. That feels very good.
Yeah, it's pretty quick, if I can say so, because 4 years is not a lot of time when you look at what you're actually doing. Mm-hmm. So, but very cool. Thank you, Sanne, for being here. It was a pleasure to talk to you.
Thanks for having me.
And for the listeners, of course, you can find the Bits vs. Bytes podcast on bitsvsbytes.com and all major podcasting platforms, and of course Twitter, Instagram, and LinkedIn. You can find it as Bits vs. Bytes. And I have a newsletter that's going every 2 weeks on Friday with 5 topics within business leadership and technology. You can find it on bitsvsbytes.com/newsletter. And I'd like to thank you for listening, and until next time.